Okay, so this idea of radians is crucial for the remainder of the course, but also radians pop up all the time in calculus, even more so than degrees. Okay, so let's talk about this. Well, we've got a circle, right? So a central angle is an angle whose vertex is at the center of the circle. So say I've got, you know, maybe some initial side and then some terminal side over here. Now, if the radius of the circle is r, so this distance right here, this is r, okay, and I have some angle here, okay, that goes up to my terminal, and this length right here on the curve, the arc length here, is also equal to r, then that angle that I have rotated is equal to 1 radian. Okay, so the angle rotated, right, 1 radian is how much is needed to be rotated in order for that arc length to be equal to the radius. That is 1 radian, okay? So if the radius of a circle is r and the length of the arc intersected by the angle, the central angle is also r, then that angle rotated exactly 1 radian. Okay, 1 radian. All right. Now, we've got a pretty interesting theorem on how to get the arc length. And so here is the formula. Arc length for a circle of radius r and a central angle of theta radians intersects or subtends an arc whose length S is S equals R times theta. So the only thing we have to do is multiply, okay? All we have to do is multiply the radius of the circle times the angle in radians. All right. If you think about it for our little example here, if I have 1 radians, r times 1 gets me r, so that formula works there. Okay. So in general, you have some circle with radius r, and you rotate some degree or some degree theta, and then that length from here to here is equal to S. So that's how we find it. We multiply, and the kicker here is that your angle is in radians. Okay, so we'll talk about in just a little bit how to convert from degrees to radians. Okay, so why does this work? Say we had a circle, right? And we have central angles, so maybe we have a central angle theta with a radius r and S here. And then maybe we have another angle, let's call it theta 1 and S1. Okay, so not necessarily the same. Then from geometry, we know that the ratio of the measures of the angles, so theta over theta 1, is equal to the ratio of those corresponding sides. So what does theta correspond with? It corresponds with S. And what does theta 1 correspond with? It corresponds with S1. Okay, so let's assume for a moment that theta 1 is 1 radian. Okay, 1 radian. So theta over theta 1 is 1 radian. Now, if that's 1 radian, okay, then I know that S1 has to be equal to R because that's the radius here, and 1 radian would equal this here. So that would mean that S1 gets replaced with R. Now to solve for S, I multiply by R on both sides, and I get S equals R theta, and that's the formula. Okay, so it's a quick little proof for you. All right. So formulas, they must be consistent with regards to the units, okay? So to see the units, however, you must go back to the equation. And so I write theta radians over 1 radian equals S, which is the length, units, whatever those units are, divided by R, length units. Okay, the S length units is equal to the R length units times theta R length units times theta radians over 1 radian. Okay. The radians divide out, right? So the radians divide out, and what's going to happen? You end up getting what? So that S length units, when the radians cancel, you're going to get R length units theta. Okay? So all we did was we multiplied both sides by this to cancel. All right? So theta appears to be the dimensionless, but in fact is measured in radians. So in using your formula, what you need to remember is that your angle is in radians. That's what's most important. Okay, so remember, for this to work, you can only have theta in radians, right? So let's do a problem. I'm going to find the length of an arc of a circle. Okay? So the radius is 2 meters, and it's subtended by a central angle of 0.25 radians. Okay, so what's going on there? Subtended, intersecting. All right, so what's the formula? Man, no biggie here, right? Formula S equals R theta. Okay, go through what's important. Radius, 2 meters. Central angle, 0.25 radians. It's already in radians for us. So I have 2 for R, for my radius, and then 0.25 for theta in radians already. So I don't have to do anything, just multiply it out. I get 0.5 meters. And that's it. Okay.